The basic functions of the four-stroke engine are briefly illustrated and explained in the introduction. You will find out what is understood by the term engine control. You will be shown how the signal paths correlate. And will be given an overview of the engine control components and how they interact. The principle of the four-stroke petrol engine has not changed throughout its development. A petrol-air mixture enters the combustion chamber while the piston is moved downwards, first stroke. The mixture is compressed by the upward moving piston and is then ignited near the top dead center, second stroke. The explosive combustion of the mixture moves the piston down. This releases the torque that acts on the crankshaft, third stroke. The combusted mixture is emitted when the piston moves upwards again, fourth stroke. At the heart of this procedure is the mixture formation and ignition. And it is precisely these two processes that are improved in modern engine control systems. The principle of engine control lies in the coordination and optimization of mixture formation and ignition. Depending on the engine's operating conditions, for example, cold start or full load, a different mixture ratio of petrol and air leads to optimum results with regard to performance, consumption, smooth running, and exhaust gas emissions. And depending on the operating conditions, various ignition times will lead to optimum engine performance. The task of electronic engine control in optimizing the mixture formation and ignition depends on several parameters, which are measured and fed into the control unit of the engine. The basic function of the engine control is to evaluate the input signals and to create output signals for engine operation. Let's look at this engine control loop using the signal paths. Sensors record the operating conditions, for example, the temperature of the air drawn in by the engine, and then pass on a corresponding input signal. The input signal is entered into the control unit along with the input signals of all the other sensors. The control unit calculates the output signals for the engine control actuators. The time of injection is changed by the actuators that are activated by the control unit, for example, the fuel injection valves. The sensors then evaluate other input signals which are once again processed by the engine control. Engine control is therefore a continuous cycle of input signals, which are measured by sensors and evaluated in the control unit before being converted into output signals for the control elements or actuators of the engine. Modern combustion engines no longer form the mixture as in historic machines, such as carburetors. Instead, the air is drawn or pressed in, for example, by a compressor or turbocharger, and the petrol is injected. It is injected in the path of the mixture supply, or, as in the case of direct injection, directly into the combustion chamber. The first component of electronic engine control, the injection system, ensures the correct time of injection in relation to the supplied air mass, and regulates the amount of fuel for the duration of the injection. The second component of the engine control system is the ignition system, the system which is responsible for igniting the mixture of petrol and air in the combustion chamber. The ignition system coordinates the ignition voltage and ignition timing with the supplied mixture and the other parameters relating to the operating conditions. The electronic engine control unit now synchronizes, in accordance with the driver's load requirements and external conditions, the two engine components, the ignition and injection systems, and coordinates them. Electronic engine control is therefore primarily concerned with recording and influencing all input and output variables in one component, the engine control unit. Please assign the terms control signal and checkback signal to the correct positions in the system diagram. Correct. The injection system as well as the ignition system are controlled by the engine control system and return checkback signals to the engine control system. Please assign the control variables to the correct components of the engine control system. Correct. The air mass and the petrol quantity are controlled by the injection system. Ignition timing and ignition voltage are controlled by the ignition system. The main task of the engine control unit is to create optimum operating conditions for the engine, depending on the driver's load requirements and external conditions. The output demanded by the driver pressing the accelerator pedal must be made available with optimum consumption values, lowest possible exhaust gas emissions, and a high degree of running smoothness. In order to meet this demand, the engine control unit must perform various tasks. It records all data relating to the operating conditions and controls all control variables for engine operation. The engine control unit adapts engine operation to the varying load conditions, for example, partial load or full load. Engine operation is also adapted to special operating conditions, such as a cold start, as well as to ambient conditions, for example, the temperature or atmospheric pressure of the air. At the same time, the engine control unit is responsible for converting the driver's load requirements, and for continual diagnosis and storage of any faults that occur. Please assign the load conditions, the operating conditions, and the ambient conditions to the diagram. Correct.